All right, so our last segment is going to be for balancing chemical equations. So it's our last piece for this unit. And we already mentioned that chemical reactions have two main parts. They have reactants and products. And we have an example here. We have carbon dioxide with water yielding um, hydrogen carbonate or carbonic acid. So reactions need to follow the law of conservation of mass. When we look at this reaction, it is balanced. That doesn't happen all the time. So we're going to just take a little preview here. How do we balance? So we're going to use this as an example on law of conservation of mass. If we look on the left side, we have one carbon, and on this side, we have one carbon. And we also have two hydrogens and two hydrogens. I purposely left oxygen last because on the reactant side, he's in two places. So now I see I have 2 plus 1, so that's giving me 3 oxygens, and over here I have 3 oxygens. Unfortunately, we are not always lucky in having reactions be balanced when we just clearly write their formulas. So we have to do some work for that. So how do we balance reactions and why? So the law of conservation of mass, we've learned that matter is neither created or destroyed. What it really does is it states that the amount and type of atoms on the reactant side of reaction must equal the amount and type of the same atom on the product side. So in other words, the reactants need to equal the products. You must have the same types of atoms, meaning the same elements on both sides, and each element must be represented the same amount of times. So there are 3 basic steps to balancing, and our first step is you write the formulas for the reaction. So we're showing here an example. We have hydrogen, and it's going to react with oxygen to form dihydrogen monoxide, basically water. But this right here is called a word equation. So step A is a word equation. And then we get to B here. This is actually where we get the step. We write the formula. So hydrogen is H2. Keep in mind it's part of Brinkelhoff, our diatomic atoms. Oxygen is O2. Once again, he's part of Brinkelhoff, so diatomic atoms. And then we write the formula for water. Notice we don't have H2O2. We have the formula for water. The subscript here, yes, is similar, not always. This subscript for the oxygen is a 2, but it's not a 2 over here. So they don't have to be the same. Subscripts do not have to be the same from left and right. So we have that written down. Now our step 2 is we need to count the atoms. So if we look on hydrogen, technically we have 2 atoms, so we have the H2. Oxygen, we have 2 atoms, so we have O2. But on this side, we have 2 hydrogens and only 1 oxygen. So 2 atoms, 2 atoms, 2 atoms, 1 atom. These are not equal. So we need to just count the atoms. We're taking inventory. What do we have when we write these formulas? And then the third step is where we actually need to use that key word there, coefficients. So we're going to change the coefficients to make the number of atoms equal on both sides. So we satisfy the law of conservation of mass. We need to make the reactants equal the products. So what we did is we started off with our hydrogen and we put a 2 in front of there. And that gives us 4 atoms. And then we look on this side, we still have 2 oxygens and we have 2 hydrogens here. Times 2 gives us 4, as well as 2 oxygens. So that's balanced. Another way you could look at it is I have an odd number of oxygens on this side, and I have an even number of oxygens on the reactant side. So how do I make an odd number even? I multiply it by 2. So now I fixed my problem. I fixed the problem with oxygen not being equal. But in doing so, now I created hydrogen not being equal. But that's an easy fix. When I look at hydrogen, I take my 2 times 2, and that gives me 4, because that's where I made that change. And now I do the same thing on this side. I put my 2 in as a coefficient on that side to make hydrogen equal. So now once again, 4 hydrogen atoms on both sides. 2 times 2 is 4. The coefficient 1 here for oxygen times the subscript 2 is 2. And on the product side, my 2 times my oxygen, my coefficient gives me 2 oxygen atoms. So you can conquer it by choosing different elements to start with, but sometimes it's easier to get rid of the odd thing and work from there, and sometimes that can create problems. So it's just a practicing thing. One of the things we said we do is we never, ever, ever change subscripts, because let's look at this. If we have, usually we have water. We like to drink water. But say for some reason when we did our reaction, we wanted to balance it. Instead of doing all the steps we just did, we said, hey, we're just going to throw a 2 there so it makes it balance. Would you want to drink a glass of hydrogen peroxide instead of water? I don't think so, unless you really want to go to the ER for a night. So we don't change subscripts. That changes the substance, and we're not changing the substance. We just want to balance it. So some tips on how to balance, and these are written in for you. You don't have to fill them in. We balance the types of atoms that appear in only one reactant and one product first. So if there's a plus sign and you see oxygen that's in 2 things on both sides, we'll have some examples. You don't want to conquer that atom first. You want to pick an element that only appears once on the reactant side and only once on the product side. We usually reserve hydrogen and oxygen after we've done all the other elements. And part of this comes in because of combustion. So we want to do carbon first and then focus on hydrogen and then focus on oxygen. That's the chain that I usually follow whenever I'm doing that. If there are the same polyatomic ions, so let's remember those could be nitrate, sulfate, phosphate, hydroxide, and that polyatomic ion appears on both sides of the equation, treat them as one unit. Don't sit there and treat everything as individual atoms if you don't have to. So let's try some examples. So we're starting here. We have chlorine, and we write it as Cl2, part of Brinkelhoff. Sodium bromide, we have the NaBr. Sodium is a +1 charge, bromide is a -1 charge, so they cancel out, making bromine. So we have Br2, he's also part of Brinkelhoff, and sodium chloride. Na is +1, Cl is -1, so those cancel out also. Now, I do want to ask you one question. What type of reaction is taking place here? We have an element and a compound forming an element and a compound. So I'm praying that you said a single replacement reaction. So let's look at the next step. You can draw it out. Some people like to make a spreadsheet underneath. It's up to you. I'm more of a check and balance. I just keep bouncing back from side to side. So when you're taking that first inventory, we have Cl2. So we have Cl2 there. So we have 2 chlorine atoms. And then I'm looking on this side, I have just 1 chlorine atom. And I look on the reactant side, I have 1 sodium. And on the product side, I have 1 sodium. On the reactant side, I have 1 bromine, and product side, I have 2 bromines. Notice the chlorines are not equal and the bromines are not equal. So we do need to balance this equation. And my favorite question is, what do you use to balance an equation? And this will most likely be on your test. The answer is coefficient. You always use coefficients to balance equations. So let's get those coefficients in there. Let's look at what we needed to do. Because we had 2 chlorines on the reactant side, a subscript 2 was added on the product side. That then impacts sodium. So sodium now has 2 on the product side, so I need to add a 2 on the reactant side. And now that has also impacted bromine. So I now have 2 bromines on this side, because we can distribute that 2 around, and I have 2 bromines on the reactant or product side. So by simply starting with picking one atom, and in this case I chose chlorine to start with, I moved over to the right side and said I need a coefficient there. As I added that coefficient, I impacted sodium. And once I impacted sodium, I had to change him over here. And by putting the 2 on the reactant side, I impacted bromine. So now I have 2 bromines. And on the product side, I had 2 bromines. So you need to walk yourself through the steps and ask yourself those questions. So let's take a look here at some more practice problems. This time we have no answers. So I'm going to ask that you try them, and I'll do the first one with you. And then I want you to take a hand at figuring them out. So whenever we're done here, I'm probably going to ask the substitute or ask you to pause, so that way you can try the other ones and then check your answers. Alright, so I'm going to focus on this one right here, the very first one. Sorry, I didn't letter them or number them. When I look at this, I see I have potassium on one side and I only have 1. I have potassium on the other side, I only have 1. I have hydrogen on the reactant side, I have 2. But I have hydrogen on the product side, and I have 1 plus 2 is 3. As far as oxygen goes, I have 1 oxygen on the reactant side, and I have 1 oxygen on the product side. So I clearly am not balanced because of the hydrogen. So how do I fix that? If I put a 2, because here I have an odd number, this side only has hydrogen present in one area. So if I try to get rid of that odd number and put a 2 over here, I now have 2 hydrogens, and excuse me, I have to sneeze, and I have now just compacted oxygen and potassium. So I have 2 hydrogens plus 2 hydrogens is 4. That's in 2 places, so I'm going to leave them alone. So I'd rather start working with potassium. So 2 times 1 is 2, so I'm going to put a 2 here. And then I'm going to look at my oxygen, because hydrogen's in 2 places, so leave them alone. I have 2 times 1, so I need to put a 2 here. So that gives me a 2 times 1. So now I have 2 potassiums on both sides. I have 2 oxygens on both sides. So now let's take a look at that hydrogen. I have 2 times 2 hydrogen, so that gives me 4. And over here I have 2 hydrogens plus 2 more. That gives me 4. So see why we leave those last. is because it's in two different places. You could be bouncing numbers left and right trying to figure that out if you keep moving them around. So the coefficients here are 2, 2, 1, and we don't write that 1. Alright, so what I would like to do is give a little pause, and I'd like you to try to work on the other three reactions. I will tell you that there probably was a little hint here. If you would write hydrogen or water, sometimes this works, not always, as HOH, and sorry, trying to use the stylus on the iPad and it's not quite the same, as HOH, you could treat this as hydroxide and hydroxide, and then you would have your hydrogen and hydrogen. And now you can see you have H2, and here you technically only have an H, so you put a 2 there. And now that makes 2 hydrogens and 2 hydroxides, and you put a 2 on the product side, that gives you your 2 hydroxides. And now we've impacted potassium. We can put a 2 in front of potassium on the reactant side. So there is that mere occasion where water you want to rewrite as HOH. So just something to think about. You don't have to do it, but it is something to think about. Alright, so that was my last little tip to try to help you out. Like I said, there are 3 other items here, so I'd like you to hit pause or have the substitute hit pause and give you a couple minutes to try them with a friend. And I'm going to stop talking now, and then when they're ready or you're ready, they can hit start up again and show the last slide. Okay, so how did you do? The first one we already did. And then if we look at the second one, I'm hoping we were okay. If you have questions, that's fine. It's something we can work on when I return or when we get back into class. But at least you're getting your feet wet and trying to see what it looks like. I always say you need to have that little Jiminy Cricket. You have to ask yourself questions. Sometimes maybe out loud and sometimes just to yourself. But you keep having to ask yourself, how many do I have on this side? How many do I have on that side? So how many do I have on this side? How many do I have on that side? What do I need to multiply by? Okay, so those are the questions I usually say to myself. How many chlorines do I have on the left? How many do I have on the right? So I have 2 on the left, 1 on the right. What do I need to multiply by? 2. Who did I impact? Lithium. So now let's fix lithium. So it is a process and series of questions that you need to ask yourself and walk yourself through the problem. So that is the last video for this section. We do have lots of practice that we need to do. We need to practice writing formulas. We also need to practice turning those formulas into chemical equations and balancing those. So this is really a skill set unit. And then we need to also classify. So before we conclude, can you do me one favor? What type of reaction is taking place in the first reaction? What type of reaction is being shown in the second reaction? What type of reaction is being shown in that third reaction? And what type of reaction is taking place for that last reaction? If you said for number 1, single replacement, you would be right. If you said for number 2, single replacement, you would be right again. If you said for the third one, it would be synthesis or combination, that would be correct. And if you said for the fourth one that we have single replacement taking place, you would be right again. So we try to start off with some basic reactions, and then class will work on more with polyatomics and parentheses.